How does tokenization work in LLMs? And why is it important? Tokenization is simply how LLMs break text into smaller pieces they can understand. And here's the key idea. Instead of reading whole sentences at once, the model works with tiny building blocks called tokens. We split the text into these blocks, turn each block into a number the model can process, and keep the vocabulary balanced so the model stays efficient without losing meaning. Think of it like turning a sentence into Lego pieces. Smaller pieces give the model flexibility, but too many pieces make things slow. Interviewers may ask why tokenization matters so much, and the simple answer is that every step in an LLM depends on these pieces being clean and consistent. Don't worry if this feels new. Tokenization becomes intuitive once you see it in action. Now let's walk through the full tokenization process so it feels concrete. Imagine you start with a sentence like, "Hello, world." First, it gets split into smaller chunks such as hello and world. Then each chunk is turned into numeric IDs the model can use during computations. After that, the neural network applies attention and generates meaningful output based on these IDs. Different tokenization methods exist because languages vary widely. English may benefit from subword units, while multilingual systems need more flexible approaches like SentencePiece that adapt to any writing system. Interviewers often ask why we use multiple methods, and a strong answer is that no single strategy works for every language or domain. Choosing the right tokenizer leads to cleaner input and better model behavior. Now that you understand the process, here's why tokenization is absolutely critical for modern LLMs. Good tokenization manages vocabulary intelligently, so even unfamiliar words get broken into meaningful pieces, instead of causing errors. It also keeps sequences shorter, which speeds up training and inference without losing context. In multilingual settings, a well-designed tokenization captures shared subword patterns, so one system can handle many languages smoothly. And from a performance standpoint, better tokens lead to stronger modeling of rare words, grammar, and relationships between concepts. Interviewers often ask how important tokenization really is, and the honest answer is that nearly everything downstream depends on getting this step right. Think of it as the foundation of the whole model pipeline. Interviewers love probing deeper here, so let's prepare for common follow-ups. If a word isn't in the vocabulary, subword tokenization breaks it into familiar pieces, so the model still understands it. When they ask how vocabulary size is chosen, explain the trade-off. A larger vocab gives more precise tokens, while a smaller one improves efficiency. They may wonder how tokenization differs across languages, and you can say character-based languages need strategies that capture meaningful chunks rather than full words. And yes, poor tokenization can absolutely hurt performance because it impacts every step afterward. If they ask about ratios, mention that English averages around 1.3 tokens per word. These answers show you understand not just what tokenization is, but how it behaves in real systems. Now let's place tokenization inside a real ML workflow, so you see how everything connects. First, we collect a large text corpus. Then, tokenization converts that text into the numeric units the model will learn from. During training, the model discovers patterns based on those tokens. During inference, the user's input is tokenized the same way, so the model can respond consistently. Once deployed, we monitor token patterns to ensure nothing drifts over time. For example, sudden spikes in unusual tokens can signal new user behavior or data issues. Think of tokenization as the bridge between raw human language and the mathematical world of neural networks. When you explain it this way in an interview, it shows you understand both the concept and its practical role in production systems. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.